So can you see my screen? Is it visible?
Yes, ma'am.
Okay, yeah. So what I was trading with that. Yeah, we were talking about the examples, means all those objects which are actually experiencing the force on them. Okay, and if I talk about the examples, you can say the all the all the objects lying on the surface of the earth. Okay, lying on the surface of the earth. Okay, just tell me one thing. If you jump, okay, if you jump, then what is happening? Suppose in case there is no gravity, okay, then what will happen? If you're jumping, you may go and you may reach the space, okay, but actually is it happening or something else is happening over here? What is happening actually? Suppose you jump, then what happens?
We push down, the gravity pulls us.
Yes. So what is happening? Suppose if you're jumping, okay, and after some time, or you can say after fraction of second or after few seconds, again you come down. Okay. Now the thing is that when you're jumping, then why are you coming back? Is there anything present over there which is actually attracting you towards the earth? So yes, what is happening? The earth is continuously applying some force on us, and what is that force? That force is your gravity. Okay. And with the help of this gravity, actually, what is happening? All the objects which are lying on the surface of the earth, or you can say that all the objects which are actually close to the surface of the earth, either they are lying close to the surface of the earth, or you can say that they are actually lying on the surface of the earth. All those objects are what? All those objects are facing a kind of force that is exerted by the earth, and that force is what? That force is nothing but your gravitational force. This is the gravity that is actually attracting all the things which are lying close to the surface of the earth, as well as all those things which are actually lying on the surface of the earth or close to the surface of the earth towards itself. Okay, so now is it clear what is gravity?
Yes, ma'am.
Okay, so what is the gravitation? If I talk about the gravitational force, you will say that every body in this universe that is actually attracting every other body with some force, okay, and that is your gravitational force. If I talk about the gravity, then this particular force is exerted by your earth, and on whom this earth is exerting the force, this earth is attracting all the objects which are actually lying on the surface of the earth, or all those objects which are actually close to the surface of the earth. Okay, so this is what? This is your gravity, and the previous one was your gravitation, or you can see your gravitational force. Okay, now the next thing is that if I talk about that, what are the advantages of this gravity? Okay, and what are the different features of this gravitational force? Let's talk about these. So if I talk about the basics, some other things, you can see that actually what is happening. Have you seen a moon that is rotating around what? Or you can say that is revolving around what? The moon is revolving around our,
Earth,
yeah, the moon is revolving around our earth. Okay. Have you ever heard that a moon got bored while revolving around the earth? So the moon went off to meet Jupiter or Saturn. Have you ever heard about that?
no, ma'am.
No, very good. So you can say that the moon never ever left its orbit. Okay. You know very well, the moon is actually revolving around the earth in a particular orbit. Okay. And the moon actually never leaves that particular orbit. Okay. And keeps on revolving around the earth. Okay. Now, what is the force that is actually exerted on the moon which forces the moon to move in this particular orbit? So what is that force, and who is exerting this force? Can you answer? Who is exerting
Gravity.
this?
With the
Yes,
help of gravity.
very good. So this force is actually nothing else. You can say that basically this force is your gravity. Okay, and this is the force which is exerted by our earth. Okay, and due to this force only, the moon actually never ever leaves the orbit and keeps on revolving around the earth. Okay, so who is exerting the force on the moon? You can say that yes, actually the earth is exerting the force on the moon, uh, which is actually forcing the moon to move in a particular orbit around the earth. Okay, now any other example which you can give me about the effect of gravity on the objects? What is happening? Natural phenomena, some natural phenomena which is actually happening due to the gravitational force. Any other example? Okay, if I ask that, okay, the rainfall that occurs, that is also due to what?
Natural thing.
Yes. So the rain, the water droplets, they are going into the space or they are moving towards the earth.
Earth.
Yes. And it is due to what? That is due to your gravitational force. Okay. Now another phenomena if I talk about the atmosphere. Okay. Atmosphere. Okay. You know that there are different layers in our atmosphere. है ना? There
Yes,
are so many layers in our atmosphere. So, have you ever heard that our atmosphere has vanished? Have you ever heard that atmosphere has vanished?
no, no.
No. Why? Because the gravitational force over Earth is actually holding this atmosphere and it is not allowing this atmosphere to actually escape. Okay, so for holding the atmosphere around the earth, who is actually playing a role? So you will say that the gravity, the force which is actually exerted by the earth, that is playing a vital role in holding our atmosphere firmly. Okay,
Yes, ma'am.
okay. And one more example that we have already covered, that is about the moon. The moon is continuously revolving around the earth, okay, and it is never leaving its orbit. So what is actually happening? So all these things are actually happening due to the force that is exerted by the earth, and that is your gravity. Okay,
Yes, ma'am.
clear? Okay, so all these are actually the phenomena that are actually occurring in our nature naturally. And who is responsible for all these phenomena? So you can say that the gravitational force of the earth, that is gravity, is actually responsible for all these natural phenomena that are actually happening in the universe. One more important thing, if we talk about the rest of the things, so any other example on which we can see the effect of the gravitational force? So you can say that yes, for example, if you jump, you come back again to the earth, again you come back to the ground. And suppose you jump, okay, then what will happen? After some time, you will again come back to the ground. Okay, and suppose if you are throwing something in the upward direction, okay, you are doing what? You are throwing something, in the upward direction. So after some time again, what's going to happen? After some time again, that object will again come to the ground. So you will see that ultimately what is happening? Ultimately, everything is coming back to the ground, and everything is coming back to the ground. That means what? That means some kind of force is actually occurring in all these things which are actually bringing these objects in the downward direction. And it is due to what? It is due to the gravitational force of the earth, which we call it as what? We call it as a gravity. Is it clear? Hello.
Ah, yes, ma'am.
Okay, good. Now, okay, so okay, after going through this thing, now let's talk about the rest of the thing. Now the next thing is that Universal law of gravitation. Actually, the main chapter starts from this particular law only. Okay. Now, if I ask you that, what is the universal law of gravitation? Have you heard about it? Have you heard about this law, about the universal law of gravitation?
Newton's law.
Newton's law. Exactly, is it? No, actually, you can say that are actually the three laws of motion, I would say. Okay. So, have you ever heard about the universal law of gravitation? Have you?
Again, none.
Okay, fine. Chalo, no issues. I'll. Okay, now. So, it's a very, very important topic, and please listen it very carefully. Okay.
Yes, ma'am.
Universal law of gravitation. Universal law of gravitation. Now, see, according to the universal law of gravitation, actually, what is happening? Let me do one thing. First of all, let me draw a diagram for you. From there, it become more clear. Suppose oh, sorry. Suppose I'm having two objects. Okay. Suppose this is my first object, and here I'm having a second object like this. Okay. Now, see what is happening. Now, suppose this is my object number one, okay, and this is my object number two. Suppose the mass of the object number one is your m1, and the mass of the object number two is your m2. Okay, is it clear till now?
Yes, ma'am.
Okay, what is happening actually? I'm having two objects, the first object and the second object. The mass of the first object is m1, and the mass of the second object is your m2. Okay, and now, suppose the distance between both these objects is how much? Suppose the distance between both these objects is, suppose, say, r. Okay. And always remember one thing, the distances are actually measured from center to center. Suppose this is the center of the first one and this is the center of the second one. So always when you're going to measure the distance between the two objects, always consider what? Always consider their centers and always take the distance from their center. Okay. And suppose the center between distance between both the centers is your r. Is it clear? Is it clear till
Yes,
now?
ma'am. Yes,
Okay,
ma'am.
so what is happening? I'm having two objects, the first object and the second object. The mass of the first object is m1 and the mass of the second object is m2. And suppose the distance between both the centers of both these objects is your r. Now, according to the universal law of gravitation, actually what is happening? Every body in this universe attracts every other body. Okay, universal law of gravitation is saying what? That every body in this universe, actually what is it doing? Every object in this universe is attracting every other object. Okay, means object one is attracting your object number two. Okay, and your object number two is attracting your object number one. Okay, now, but for this, what we need? For attracting anything, you need some kind of what? For attracting anything in this universe, you need what? You need force for that. You know this thing? You know this thing? For attracting anything in this universe, you need what? You need force for that. Okay. So what is actually happening? According to the universal law of gravitation, every body in this universe is attracting every other body with a force. Means your object number one is actually attracting your object number two, and your object number two is actually attracting your object number one, and both these objects are exerting what? Both these objects are exerting force on each other. Means object number one is exerting force on object number two, and object number two is exerting force on object number one. Now, let's move on to this force kind of thing. Okay, so till now is it clear?
Yes, ma'am.
Okay. Now this force that we have written over here, this force is directly proportional to what? This force is directly proportional to the product of the masses. That means if I'm saying directly proportional means what? Directly proportional means if one thing is getting increased, then other thing is also getting increased. Means suppose if the product of the masses is increasing, then the force, this value of force is actually also increasing. Okay, and if the value of this mass is decreasing, then the value of the force is also decreasing. And the second thing is that this force is actually inversely proportional to what? This force is inversely proportional to the square of the distance between them. Okay. So you might be knowing then what is the universal law of gravitation. Do you? Do you know what is the universal law of gravitation? So yeah, Dhanashri, we were talking about the universal law of gravitation, and where were we? We were on the very important note. That is, let me go straight once again. So what we were talking about, we are having two objects, the first object and the second object. The mass of the first object is your m1, and the mass of the second object is your m2. So according to the universal law of gravitation, actually what is happening? Every body in this universe, it attracts every other body, and for attracting anything, you need force for that. Okay. So what is actually happening? Obviously, M1 is attracting your object M2, M2 is attracting your object M1, and both of them are exerting some force on each other. Now, if we go into the particulars of this particular force, so this force that is directly proportional to what? That this force is directly proportional to the product of the masses. Okay, and if we talk about the rest of the thing, the other factor is the force is inversely proportional to what? The force is inversely proportional to the square of the distance between them. And what was the distance between both these objects? That is your actually r. Okay, now if you combine both these equations, so what is the final equation that you would be getting? You would be getting that force is directly proportional to m1 m2 upon what? m1 m2 upon r square. Okay, so this is the final thing that we would be getting. Now the next important thing, whenever we are having a proportionality sign and whenever you are removing this proportionality sign, then for that you need to introduce, and whenever you want to introduce an equal to sign, then there comes a constant along with the equal to. And if we talk about this particular equation, then what is the constant that we would be writing? So it would be your f is equal to what? F is equal to g. This is what? This is not a small g. This is your capital G. So just keep this thing in mind. G m1 m2 upon what? G m1 m2 upon r square. Okay. So from here you can see that yes, actually what is happening actually when we are removing this proportionality sign, and we are introducing this equal to sign, then along with the equal to sign we are also introducing one, what we are also introducing one constant. And what is this? This is your capital G, and we call this capital G as a universal gravitational constant. Is it clear?
Yes, ma'am. Then what
Okay.
about small g, ma'am?
Yeah, actually what is happening, the small g is nothing but your gravity. Okay, just now we had a brief discussion about the gravity, right?
Yes,
Gravity
ma'am.
is what? The force that is exerted by the earth on all the objects, that is the gravity. And here this gravity is actually represented by a small g. Okay, and if you're talking about the capital G, that is what? That is your universal gravitational constant. And always remember one thing, that whenever we are talking about the constant term, so constant is what? You might have gone through the constants and the variables in your mathematics, isn't it?
Yes,
है ना?
ma'am.
You must have gone through the constants meaning. So constants are what? Constants are those you can say values which actually don't change, and variables are those values which might change. Okay, so if you are talking that your capital G is your constant, then what does it mean? That means its value is never and ever going to change, and it will have a constant value. Okay, is it clear?
Yes, ma'am. Ma'am,
So
can
this,
you explain about the proportional sign?
yeah, obviously, I'm going to discuss more about this. First of all, actually, I was in brief talking about the statement of the universal law of gravitation, which you will generally find in your books. So, what is the universal law of gravitation? Obviously, we'll going to have a detailed discussion about this. Okay, so what is the universal law of gravitation? According to the universal law of gravitation, every body in this universe attracts every other body, and with what? Obviously with a force. Okay, and that force with which every other body is attracting every other body, that is force is directly proportional to what? That force is directly proportional to the product of the masses, and it is inversely proportional to the square of the distance between them. Now, when we are going to combine both these equations, then what you are going to get? You are going to get this particular expression that we have written over here. You can say that yes, F is proportional to what? F is proportional to m1 m2 upon r square. Okay, and always remember one thing, this proportionality sign, whenever you are going to replace this proportionality sign with the equal to sign, always and always we place some constant along with that. And in this particular case, what is that constant? That is your capital G, and we call it as a universal gravitational constant. Okay, is it clear till now?
Yes, ma'am.
Yes,
Okay.
ma'am.
Okay. Now, one more important thing. Just now, I told you that it is a constant. Okay. And you know very well the value of the constant is obviously not going to change. है ना? Can we change the value of a constant?
No.
No, ma'am.
Never and never we can change the value of the constant. Okay. Now, so here when I'm writing about the constant, means when I'm writing about the capital G, so obviously as this is also a constant, so obviously this is also going to have a particular value, isn't it? It's capital G, it might be having some fixed value,
Yes,
isn't
ma'am.
it? Okay, and what is this value? Anybody of you can who remember?
FR square upon में M1 multiply M2. Oh,
No,
sorry,
that
ma'am.
is the equation. I'm talking about the
Yes,
value of
ma'am.
the
Value
6.67
6.7
in
10 k power
into 10.
minus 11
Yes,
Newton
very
meter
good.
square.
Yes. So this is the value. And if I talk about the unit, so what is the unit? It is Newton meter square per kg square. Okay. Now we'll discuss that how we got this unit. Okay. So first of all, this value should be, you have to means remember this particular value because it's a very common value. Okay. So what is your capital G representing over here? See, capital G is your constant, and what is that? That is the universal gravitational constant. Okay, and as it is a constant, so it must be having some fixed value. And what is this value that we have already written over here? And what is that? That is your 6.67 into 10 raised to the power minus 11 Newton meter square per kg square. Is it clear?
Yes,
Is
ma'am.
this value clear to everyone?
Yes, ma'am.
Okay, very good. Now let's talk about the unit, means how we got this unit. Okay, let's have a brief discussion about this. Okay, now tell me, what is the formula of force that we have just written? So F is equal to G m1 m2 upon r square. Okay, and we are supposed to find out the value of what? We are supposed to find out the value of your capital G. So what we are going to do? We are going to keep G on one side, and rest all the things will take them to the other side. Now, if you are doing this, so what we are getting? G is equal to what? This r square will go over here. So we'll get f r square upon what? Upon. Now this m1 and m2 that will go over in the denominator part. So in the denominator we are going to get m1 m2. Is it clear? Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay, very good. Now just tell me one thing. What is the unit of force? That is your
Newton.
very good Newton. And what is this R representing here? R is representing the distance between the two objects. है ना? M1 and M2. We were having two objects, M1 and M2. And this R square is representing the distance between both the objects. So what is the SI unit of distance?
Meter, ma'am.
Very good. And here we have R square. So what we are going to write over here? So here we are going to write meter square. Okay. Now, the
Square.
numerator part is
Yes,
complete.
ma'am.
Now, let's come on to the denominator part. Now, just tell me one thing. What is the SI unit of mass? SI unit of mass is your kg.
kg.
Yeah. Now, for M1, we are going to write kg. And for the M2 also, we are going to write kg. So, can we write it at like this, kg square? Can we write it like this?
Yes, ma'am.
Yes, very good. So, what is the ultimate value that we are getting? Means the unit that we are getting Newton meter square per kg square. So, this is the unit actually we are getting for what? This is a unit actually we are getting for the universal gravitational constant. And what is the value that we have already means read about? That is your 6.67 into 10 raised to the power minus 11. So is it clear to both of you?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. So what are the things that we have discussed in today's session? First of all, we started with the, you can say, definition of gravitation. Then we had a brief discussion about the gravity. Then we had a discussion about the few phenomena in nature actually, where we are actually, you can say, can where we can simply see the effect of gravity. Okay, for example, we talked about the revolution of the moon around the earth. So it is revolving around the earth in a particular orbit, and for the motion of the moon, who is responsible? That is the gravitational force of the earth, who is actually holding the moon. Then if you talk about another phenomena of nature, you will say that the atmosphere, है ना, who is holding this atmosphere around the earth? So it is the gravitational force of the earth. Okay. Now, if I talk about the rain, if I talk about the rest of so many things, so all those things are actually happening due to what? All these things are actually happening due to the gravitational force of the earth. Okay. Now, we had a brief discussion about the day-to-day activities where we can actually see the effect of, you can say, the gravitational force. So, for example, if I ask Anishri that suppose if you jump, then what is going to happen? Then, of course, after some seconds or after some fraction of second, you will again come back to the earth, or you can say that again, you will come back to the ground. So, it is due to what? It is actually happening due to the gravitational force of the earth. For example, if you're throwing a ball in the upward direction, then again, after some time, the ball will return back to us. And it is due to what? That is due to the gravitational force of the earth. So you can say that at each and every moment, at each and every point of our life, what is actually happening? The gravitational force is acting on us. At present, also, the gravitational force is actually acting upon us. Okay. Now, after going through all these basic things, we studied about the universal law of gravitation, and it is basically the most important topic from where our chapter actually starts. Okay, and this topic is not complete. We'll have a, you can say, in depth discussion of this topic in our next session. So, if Neha and Dhanashree, if you have any doubt in today's session, you can ask me, or you can ask me the doubts in the next session. And please remember one thing, whenever you are coming for the next session, please go through the topics that we have covered in today's session so that you can link the next topic very well to the today's topic. So, do you have any doubt? Any you want to ask anything? You can ask me. Otherwise, we can end up with a session and meet in the next session. Do you have any doubts?
No, ma'am.
No, ma'am.
Okay, okay. So let's do one thing. Let's meet in the next session. And please remember one thing. Whenever you come for the class, please do keep on your videos for the entire session. Okay.
Okay,
So
ma'am.
okay. So from next time, whenever you are logging into any class, not only mine or any other class, please do log in from such a device from where you can actually your video is clearly visible to us. Okay. Okay. So let's meet in the next session. Till then, bye bye. Take care and Happy New Year to both of you.
Same to you, ma'am.
Okay. Thank you. Bye
Thank
bye.
you, ma'am. Bye, ma'am.
Bye bye, ma'am.